You may already know that many high-tech companies like Google, Tesla, and Uber are all trying to create self-driving cars. Does that sound cool? Do you want to build one of your own but don't know how? It's not that difficult to get started. In this series of videos, I'll show you how to do that. I've also introduced some necessary knowledge to understand how it works. As a beginner, it's better to choose a kit to start from than build everything from scratch. I choose Playcard to start with. It's a very good starting point for beginners. First, it has everything you need in a robotic car, except for the Raspberry Pi and the batteries, so you can quickly get a working car. Second, it comes with an open-source Python API to control the car. Once assembled and get it to work, you can go deep into the code to understand it and tinker it in your way. The pieces of hardware you need are Playcard V, Raspberry Pi, and batteries. For Raspberry Pi, if you only buy the motherboard, then you will also need to buy a microSD card and install the system by yourself. If you buy a Raspberry Pi kit, the included microSD card should already have the system installed. Playcard comes with a detailed manual book. It has very clear instructions for how to assemble, including how to install the system. I will not repeat it here. Once assembled and have the codes installed, you can remote control the car through a PC or phone to move and spy. Now, let's look a bit deeper. In this video, I'll focus on the hardware. The heart is the Raspberry Pi. Raspberry Pi is a small computer. You can do almost everything you can do on a computer with Raspberry Pi. It's small, cheap, yet powerful. The 40 pins make it very convenient to control mechanics such as robots, mechanical arm, etc. Today we will talk about three types of pins: power, GPIO, and I2C. Power is easy to understand. Raspberry Pi has 8 ground ports, 2 5 watts power output, and 2 3.3 watts power output. They can provide power to the device you would like to control. However, in a lot of projects, especially the complex ones, you will need external power to power all your devices. GPIO means General Purpose Input-Output. It can be used as input or output or both. As input, it can receive on-off commands to the computer or get data from sensors. There are tons of sensors you can use with Raspberry Pi: temperature, air pressure, voice, light, motion, info, ultrasonic, on and on. These inputs can be processed by Raspberry Pi to generate output signals to control devices. As output, GPIO sends pulse-wise modulation to control devices. Here, the duty cycle is the most important concept. It's the relation between the time that the pulse is high divided by the wave period. By changing the duty cycle, we can control servo angle, light brightness, motor speed, etc. I2C are 2 special pins. It is a multi-bus used to connect the peripheral to computers and embedded systems. There are a lot of details on how I2C works. Here, it's good enough to consider it as something like a power strip. You can connect it to the outlet, and you can plug a lot of stuff on it. It will dramatically increase the number of devices that a Raspberry Pi can control. Better than a power strip, where if you turn it off, all devices on it will be off. Each device connected with I2C will have its own address, which means they can be controlled independently. Motors. 2 types of motors are used by Playcard: standard DC motor and servo motor. When power is supplied to a standard DC motor, it will start spinning until the power is removed. PWM can be used to control the speed. The wider the pulse, the faster the speed. In Playcard, 2 standard DC motors were used to control the 2 back wheels. Servo motors do not rotate freely like a standard DC motor. The angle of rotation is limited to 100 degrees back and forth. It has 3 input wires, 2 for power, the other one for the PWM control signal. The PWM tells the servo motor which angles to move to, and when moved there, it will hold the position unless the external force is bigger than what it can resist. There are 3 servo motors in Playcard. 1 is to control the steering of the front wheels. 2 are used to control the camera movement, so our camera can look around. Now you may say, great, I have Raspberry Pi and I have the motors. Now I can control them. But there are 3 other components. What are they used for? Now we'll get to them. First, let's look at the robot head. It's attached on top of the Raspberry Pi, just like a hat. But actually, HAT means hardware attached on top. Hats are expansion boards that connect to the Raspberry Pi's set of 40 GPIO pins and add functionalities such as lights, motors, sensors, and fans, etc. There are hundreds if not thousands of heads for Raspberry Pi. Each may have a specific focus. For example, Sense head to add a bunch of sensors. The LED matrix head, sound effect head, capacitive touch head, etc. The one in the Playcard package is for robot control. It looks like this. In the assembled Playcard, we will use these ports. 3. The I2C port to connect to the PWM driver. You can see there are 3 I2C ports on this head, which means it can connect to 3 devices. Currently, we only use one of them. 4. Power output to the PWM driver. 6. Motor control ports output power and direction signal to the motor driver. 7. Switch to turn it on and off. 8. The power indicator indicating the input power. If no indicator is on, you need to take batteries to charge. 9. Power port to take power in. The ports that haven't been used are 1 and 2, digital and analog ports that can be used to connect sensors. 5. A serial port with power that can work with a wide range of devices. For example, used with the SoundFounder serial to USB can turn it into a USB port. Next, we will talk about the PWM driver. We have talked about how the Raspberry Pi's GPIO pin can output PWM signals, but using a PWM driver is a convenient and neater way to do so. The PWM driver with Playcard has 16 channels, which means it can control 16 motors. We have used 3 in Playcard to control the 3 servo motors. It has 2 I2C ports. One of them is connected to the robot head to take control signals. Now you see how I2C devices can be nested to expand the number of devices to control. The last one is the motors driver. It's used to control the 2 standard DC motors. Port 1 takes power and direction control signals, meaning forward or backward, from the robot head. Port 2 takes signal from the PWM driver to control the speed. Port 3 sends signals to the 2 motors. Now let's take a look at how these components are connected. Power connection. The output of the battery connects to the power input of the robot head. One important thing about the robot head here is that it can power the Raspberry Pi through the GPIO pins, so we don't need to connect power to the Raspberry Pi separately. The robot head's power output connects to the PWM driver's power inputs. The motor driver is powered by the 2 power pins in the motor driver port. Control signals connection. Servo motor control. Robot head's I2C port connects to the PWM driver's I2C port. Then the 3 servo motors are connected to the 3 of the channels. Each one uses all 3 pins for plus, ground, and control. DC motor control. As mentioned before, the power comes from the motor control port of the robot head. The direction signal also comes from the motor control port. The 2 PWM signals for speeds come from the PWM driver. Here you can see that since it already gets power, it only needs 1 wire to connect to the PWM signal for each channel. Now, when you need the car to move forward or backward, the signal goes from the motor control port to the motor driver, then to the DC motor to control the direction, and from the I2C on robot head to I2C on PWM driver, then through the 2 PWM pin to the motor driver, then to the DC motor to control the speed. When you need to steer, the signal goes from the I2C on robot head to I2C on the PWM driver, then goes to the steering motor through the PWM pin to tell it which angle to steer to. Similar things happen when you need to control the pan and tilt servo for the camera. Now you get an idea about the components in the Playcard. In the next video, we'll go into the codes to see how those control signals were sent.